Right? Having said this, if I need to understand how this differentiation works, why did I even speak about slope of a line and function before coming to differentiation? It is basically differentiation, I would call it like this. It is basically the combination of those two. I told you, right? Slope is defined for whom? Slope is defined only for a straight line. But if at all you have a curve like this, if somebody asks you to define the slope of it, then you need to draw a tangent at that point. You draw a tangent at that point, right? The slope of the tangent at that point, I'll come to this. Slope of the tangent at the point is what is called as dy by dx. Means delta is replaced with d. D. It's an infinitesimally small value. I'll tell you why this happens. Infinite. So that is why when you talk about a curve, slope is defined at a point. So dy by dx means slope of the tangent. What did I mention? Slope of the tangent at the point. I didn't say slope of the tangent and leave it. Okay, but you need to understand why this is happening. Listen to this carefully. If suppose I have a shape like this. Suppose I have a shape like this, which is x and y. Right? If I draw a line like this, it is a line, it is not a chord. It's not a line segment. So if I draw a line like this, if I take this point to be A and this point to be B, right? Then what is the name given to this line? Any idea? What is the name of a line which cuts the curve at more than one point? Sorry? It's called secant. It's called as a secant. So when will a secant become a chord? When it becomes a line segment. You're able to understand? So line which cuts the curve at more than one point is called as a secant. Right? Now, if I keep this point fixed, right? What I'm going to do is I will draw another line in this way. Let me call this as B dash. Now what has happened? This point B has traveled towards B dash in this direction. Are you able to see that the distance between them has decreased? Right. So can I call this as a line? Can I call this as a line? Means on the curve, I took 2 points. Let them be x1, y1, and let this be x2, y2. Will I be able to define the slope of AB? What is the slope of AB? Delta y by y2 minus y1 by x2 minus x1. Right. Now A is fixed, which is x1, y1. B prime is, let me call it as x3, y3. Now I'll be able to define the slope for it. Will I be able to define the slope for AB dash? Yes, I can define. Now what I'll do is I'll move this B dash even more closer to A. Let me call it as B double dash. Right. So as I keep this point fixed and as I move this B closer to point A, what is happening to that secant? So the distance is decreasing first of all, and at one point, as you keep moving closer, right, that secant will become a tangent. So you define the slope of the secant, right? As you kept moving closer, you're still defining the slope of the secant only. But how did that secant become? It became a tangent. A and B will be very close to each other. They'll not coincide. They'll be very, very, very close to each other that you need 1000x zoom to see how close they are. Let's say you put it under a microscope and see, right? They'll be very close to each other, but if you see with the naked eye, it will appear as if it is a tangent. So this differentiation falls under a branch of mathematics called as calculus. And this calculus, what is actually happening is, here also what did you find? Actually, what did I say? Slope of the tangent at that point, right? But that's an approximate value. You're actually finding the slope of secant. But how is that secant appearing to our eyes? It as a tangent because A and B are very close to each other. So that is why you call those kind of values as infinitesimally small. This is how it is written. So dy by dx is basically delta y by delta x only, provided the distance between x is small. You write it like this, don't get scared. I'll just tell you what it is. You know it is enough. So it is called as limit delta x tends to 0. You read it as limit delta x tends to 0. Delta y by delta x is what is called as dy by dx. So to put it very simple, differentiation and slope, they both are seen. Right? But when will you differentiate? I'll come to that. But when will you differentiate? When you need to find when you don't have a straight line in the first case, right? Means when you don't have a straight line, you draw a tangent at that point and find the slope of the tangent. That is what is called as dy by dx. So it will take some time for you to understand. Don't overthink. I told you I'll give you the reason. I gave it. Okay, you will understand it slowly. This is very high on the first day. Okay, so don't think too much. Your job is only to know the formula, apply it. Where to apply it, I'll teach you. But all these things, I'm building it because maybe after 3-4 months down the line, once your maturity levels increase, you will be able to understand. You will. Is that point clear? See, if at all, I know it is tough because you have not seen these kind of, I directly went into calculus. Calculus directly from 10th to 11th is not the right thing. But as of now, know what is the reason. If somebody asks you why you differentiate, right? What will you say? This is the answer. If somebody puts a question to you, tell me why do you differentiate? What will you say? I'm differentiating to find the slope of the tangent to a curve at a particular point. That's it. What is the answer? To find the slope of the tangent to whom? To a curve at a particular point. That is what you're doing. Okay, if I directly tell you what is slope, you would have not understood. That is why I had to come from the basics. Now, is that registered? Because I'll tell you what people do know when somebody asks why you differentiate to make the value small. That's not the right answer. You don't differentiate to make the value small. You are no one to make the value small. When the values are small, you differentiate. Right? To find something called as instantaneous value. So first learn this. I'll give you the set of formulae. I'll relate it to physics, then you will understand. So by the end of the session, I promise you will understand why you're doing it. Okay? Please make a note of this. Limit delta x tends to 0, delta y by delta. Delta x tends to 0. Tends to 0, na, meaning I told you, A and B are not the same points. A and B will be so close to each other that they appear to us like they are the same points. They are not. Calculus is approximation. Calculus is not exact value. It is an approximate value, meaning, yes. So that is why it is not equal to, it is tending to 0. Meaning, this will be 0 point, let's say some 100 zeros and a 1. It is that small. You will substitute. But actual meaning is this. See, because you cannot take what is that approximate value. See, somebody tends to 0. For you, it can be 0 point, 100 zeros and a 1. For me, it can be 0 point, 101 zeros and a 1. So which value will you take? Then it will be a debatable topic. That is why you substitute the value. I repeat, calculus is approximation. It's not exact value. Especially differentiation. That's not how the story starts, right? That's not how the discovery went. See, the concept is somebody started with a secant. They raised a question, same question which you asked, when slope is defined only for a straight line, then what about curves? Can we not define the straight line as slope at all? Is what they thought of. Then what they did is they kept one of the points fixed. They started moving the other point along the curve, so that the distance between the points slowly started decreasing. And at one point, it became in such a way that the distance between them is so small that the secant itself will appear like a. You need not do this at all. You will not do this. You know the formula, you'll apply it. That's it. But I'm saying how that formula has come because of that. I'm explaining what is the significance of. Because I don't want you to be like the other guy saying the differentiation, make the value small. It's an insult to me. Somebody asks you, say, you're finding the slope of a tangent to a curve at a particular. See, if you know finite values, if there is a finite difference existing between the readings, then you will take delta. If the value is small, then you will take differentiation. I told you, by the end of the session, you will get the answer to everything. Because delta and d appear to be same, but there is a slight difference. I'll come to that. Differentiation is done to find the slope of a tangent to a curve, at a particular point. Limit, you read it as limit delta x tends to 0. You can write it down. First, tends is an arrow mark. Rightward arrow mark. Limit is the one which leads to differentiation. Now we can't explain limits. Function a heavy topic. Limits okay, as of now, just know that something like this exists. Okay, I'll give you the set of formulae, use it, then we'll connect it to physics and understand when to use differentiation, when to use. So that your third chapter becomes easy. So all these things will start with your third chapter. D is called as derivative. Derivative. You read it as derivative of y with respect to x. You read it as derivative of y with WRT means with respect to x. So basically, the numerator is the variable, denominator is the numerator is a dependent function, denominator is an independent function. I told you y is equal to f of x. No, the y is always in the numerator, x is the denominator. Suppose you can ask me a question, sir, can't we define x is equal to f of y? You can. That's up to you. But whenever you write something like this, you're trying to tell the reader that left side value is dependent, right side value is independent. For example, I gave you a question, no, x is equal to. So what is the difference? I just change the values. I just change the variables. But here, if they take the exact meaning of x and y, right, then the x and the y coordinate will get interchanged. You're able to understand? Right. So if I want to differentiate this, right, I'll not write it as dy by dx. I'll write it as dx. Because derivative of dependent variable with respect to the independent variable.